Hey folks, Michael Johnson. Welcome to this week's Energy Sketch. If you've ever driven down Highway 15 in Montreal near Verdun, then you've seen this strange looking building here. This is the Verdun test bed of Siemens Energy, and this is where we test our aeroderivative gas turbines before they're shipped out to our customers around the world. And here's an aerial view. And I spent many late nights here in this test bed in the early days of my career with Rolls-Royce Energy at the time, eating a lot of local pizza and testing out different engine designs. And you notice at the top of the picture those green buildings there. That's the Atwater water filtration plant. So there's a story there that I'll get into a little bit. And there's a thread here around this idea of having local distributed power plants and how that's important for the robustness and resilience of our energy systems. So back in 1998 was the great ice storm in Quebec, and a lot of the power infrastructure crumbled under the weight of the freezing rain that built up on all of the pylons and the power lines and made them so heavy it just crumbled a lot of the infrastructure. And several weeks the city was without power. And if you take a look at the map here showing Quebec's power infrastructure, it's really quite interesting and unique. Essentially, there's a lot of hydro dams, right, in the north going into James Bay, in this area, while all the population is really concentrated in the lower part of the province. So we need to have these long transmission lines that bring that power into the high demand centers. And then during this ice storm, basically a lot of these were basically cut off. So there was no power to a large amount of population, and there was a risk. It was apparently like a couple of days until we ran out of drinking water in the city of Montreal. So what was done was an agreement was made between Rolls-Royce and the city of Montreal to install this test bed, and which is essentially a power plant. And so they are basically on standby during the winter months between the 1st of December and the end of March. Within 24 hours or so, the teams would be able to install an engine and start producing power in order to provide electricity for the two major water filtration, water treatment plants that provide all the drinking water for most of the island of Montreal. And there's a further thread here about this idea of resilience and robustness of our energy and power systems. And so as we build up renewables, those are spread out, they're scattered, they could be far away in regions where there's abundant wind and solar, and that energy needs to be transported to those demand centers. And there will be in the future, and there is now, large, long periods of time where there will be reduced wind, reduced solar. You could call them the sort of doldrum period. So we need to have a robust storage of energy that can get us through those doldrum periods. And also when infrastructure gets damaged, when things like this ice storm happen, there's a need for really resilient backup systems to be distributed around the large population centers. So I believe there's an opportunity for installations such as this one to be rapidly available and also to decarbonize and have decarbonized backup power. And I'll get into that in future episodes, some more details and technical details around what that might look like in the future. But for now, it's just a nice story about some of our infrastructure here and some of the nice partnerships that have happened between this engine company and the city of Montreal to provide resilient and robust power so that we always have good, clean drinking water. So that's it for this week's Energy Sketch, folks. Thanks so much for tuning in. And next one coming up on Monday, 12 p.m., youtube.com/@EnergySketch. Please subscribe, hit the like, hit the bell, all the good stuff. See you later. Toodaloo.